God. Okay, Bismillah ar-Rahman ar-Rahim. So we are on a Java programming. Okay, I will see the syllabus. I have not seen the syllabus yet. And firstly, the introduction of the Java programming. That's what we're going to do right now. So what I'm saying is we had a C++ languages, beautiful languages like C++ and others, but we come up with the Java. So why we do that? Why we need another language called Java when we already had a languages like C++ and all? And they were like, it was I guess in the 1991 when the James Gosling, okay, and Peter Norton. It's a Peter Norton and James Gosling. They pull up actually a project called a Green Project, and they created the Java actually firstly called as Oak. They called it as an Oak, O-A-K, because they had an oak tree near where they worked. They call it an Oak. But later on, it was like kind of a funny thing. They named it the Java. But Java is kind of a it's an amalgam of many languages. One of them is C++, and we had what's called a Nicholas. One is called as a Nicholas. Okay, Nicholas Wirth. He who has created Pascal. Okay, they combined what is in C++, what is in Pascal, and all that, and made the Java. Okay, and then Java kicked it basically because of one thing. Maybe we have that thing in the note. Let's see. We have on the slide those things. So okay, it's saying why Java is important. Because there's one thing here, what's called the portability. Okay, this we have to understand why Java becomes so famous, because of the portability. So what does the portability mean? 90% of devices, they are embedded. Now, maximum time we see the computers, laptops, and mobile phones. The mobile phones and all, they are not the devices, actual devices in the world where the Java runs. It is the embedded systems where the Java runs. It is just I don't know, I'm saying 90%, I should say 99%. Just 1% of the devices are your computers and laptops and all. Rest are embedded systems. You have Cadillac car, it has around 60 processors in it. Okay, today whatever you do, you have a small set-top box, it's having a processor and Java is running in it. You have any device, okay, which is running on some kind of a processor, is having a what is it called, the embedded system, and Java is there. So Java is there because it is portable. It is very portable. Okay, that is why it is, we say, hey, Java is becoming famous because of the portability. It can be to the 99% and also to your whatever that is, because we have a Java, different versions of Java. We've got J2SE, standard Java 2 standard edition. This is what your computers and all run about. We have J2EE, enterprise edition. If you have to develop the enterprise softwares for big, huge companies, they develop the softwares, and we have for that the J2EE. We have a Java card. Okay, we have a Java card technology which works on the card. We have J2ME, mobile edition. Okay, Java 2 mobile edition, which was before Android, we had a J2ME. Okay, I have one of the YouTube channel playlist on J2ME also. And we have the Androids and all which work with the Java and all. So Java is actually literally everywhere. Java is on every platform on the planet. That is why Java become famous. It is everywhere. It's on everyone. You name it. You name it. You mobile, embedded devices, desktops, servers. Okay. We have here the applets, for example, which work in the browsers. Okay, the small Java programs which run in the browser called applets. We have servlets which work in the servers, the big servers. We have the client-side Java. We have the backend Java. So Java is literally everywhere. There's no such thing where the Java is not there. And Java has many, many things like portability and security. That is why we moved from C++ to this, not C actually, because C is not object-oriented. So we shouldn't talk about the C. Rather, we should say C++, which was the object-oriented programming language. And we have moved towards more portability and security. And that is why we had a Java, firstly. Java came into being, right? And it was the Sun Microsystem, I told you, James Gosling and Peter Norton in 1991. They started this Java stuff and all. And then there comes a lot of versions. They call it as an Oak. Then later in 1995, they call it as Java. Then it had different versions. If I put up this Wikipedia here, okay, let me get this browser here, Wikipedia. This is on the Wikipedia, the Java JDK beta. What is the JDK? We'll discuss it. We'll discuss what is JDK and JRE. These are two important things we need to know today. We go at least knowing what is JRE and what is JDK. Then we had different versions with the different dates. You can see it here. And when we reach it to the on 2004, J2SE 5.0, we didn't say 1.5. We called it 5.0 rather than 1.5. This was a one change. And we had a lot of things like for each loop, auto boxing. We had these things in there, metadata and all. They come up here. We not only have the new version, we had a lot of functionalities and features also here. Different versions, we had these things. Then came the J2SE 6, and when it comes to 6, we have dropped to the 0.0. Okay, in the 2006, when the Java SE 6 comes in, so we drop to the 0.2. We're not saying now the 6.0. It is 6 only. Okay, when we said the 5, we drop to the 1.5. We went into the 5.0, calling it 5.0, not 1.5. But here we called it Java not 6.0, called it 6. Then 7, then 8, then 9, 10, 11, 12, and today we have a 16, Java SE 16. If you go to the saying the Java, you will get the JDK, for example, JDK. Okay, download, and you will get and it's taken by the Oracle, by the ways. And if you can see, it is taken by the Oracle, Java SE 8, taken by Oracle. So you will have the Oracle site where you will find the JDK, Java Development Kit. Okay, Java Development Kit has everything for us to develop. We will understand what it has. It has JRE, it has it has compilers in it, it has APIs, application programming interfaces in it. It has everything what you need to develop. So you have to download it. So you want to download it, right? Okay, and then all the stuff, and then choose the operating system you have and download it. That's it, whatever. Now I told you that there are many editions of like J2SE, J2ME, J2EE, Java Card technologies, and many more. So I am saying Java is an object-oriented language. What does that mean? By tomorrow, anybody I'm keeping today only giving a little relaxation in not keeping cameras on, but by tomorrow anybody without camera will be removed. Simple as it is. Okay, so what is object-oriented language? Yes, speak up. I'm asking questions to all of you. Yes.
सर जिसमें वो 5 paradigms होते हैं, abstraction, encapsulations, inheritance, and
basically in short we say which deals with the objects, right? Where we have objects. But in C++ we have seen that main was outside the class. We have a classes, okay? Basically the objects we create out of what is the class, and what is the difference between class and object? What is the difference between class and object?
Object is an instance of class.
So what does that mean?
Class is just a description. Class is just a blueprint.
Yes.
Template.
Class is only a template, it's a design. Okay. And when we create object of that class, it comes into being. Like we say human being. The God created human being. It's just it is an idea that human being will have eyes, it will have this, it will have this. Same way you create a C++ class, which may have 20 arrays, this much of data, but it is nowhere in a RAM unless you don't instantiate it, what Zahid said. we instantiate that class and create an object which has, say for example, in C++ we had a class called ABC class, okay, and it has, say for example, some lot of data and functionalities. Tomorrow of this class ABC, okay, this is a class ABC, I'm creating OB1. So which is class, which is object?
Class ABC. Class is ABC.
Class is ABC. What is OB1?
Object of class ABC.
So is OB1 object of class ABC? I'm saying this is wrong. Who will
अभी नहीं
explain
है।
why? नहीं बनाया, मानो बनाया मैंने ABC of type ABC, मैंने OB1 बनाया. मैंने बनाया, ऑब्जेक्ट खड़ा किया मैंने, ऑब्जेक्ट है, बन गया है. But is this OB1 object? No, it is a reference variable. It is just a pointer. It is a reference variable. It is a pointer which points to the object, which is created using this class as a design template. Okay, there are some chats also coming up here. Okay, chat. Okay, somebody is saying class is a template and object is runtime entity constructor call and all. I don't know. Danish Fayaz, you can open up your mic, you can speak. No need to chat. But if at all someone chats, I will put up it here on this side. Okay, it's a reference variable. It's not an object. It's just a pointer which points to where the object is, where the actual object is. Actual object is in somewhere in a memory. Okay, created what the class says. Okay, nice. So, is Java pure object-oriented language or not? One difference I will tell you is in Java, everything is in the class. You had a main in your C++ which was outside the class. आपको BC में था ये Java? क्योंकि BC को मैंने Java पढ़ा है. हाँ?
Yes sir. BC में था, लेकिन उतनी डिटेल में नहीं पढ़ा. So 5th 6th semester में.
है ना, था ना, क्योंकि मैंने पढ़ाया ना परसों ही, पिछले साल ही मैंने BC को पढ़ाया था ये. Fahim Shaukat Mani. Okay, anyways, no, not a problem. What I am saying is, in the Java, everything is in the class. We create a class, even your main is inside the class, not outside the class. This is the one difference. Second thing is, but Java is not the pure object-oriented language, because we still have here the primitive data types. We have like int, char, and all. We have that in the Java also, but we have also their classes also. Okay, that's what's called the wrapper classes. We can use. We have only 10 minutes left. We have a wrapper classes which actually wrap and create object of those primitive data types. We can do that also. Okay, nice. Now this is the most important thing in the Java. That is Vora. Write once, run anywhere. This is what I told you, that we had the Nicholas Wirth, which has created the Pascal. Okay, I wrote it somewhere, I don't know. Here, Nicholas Wirth, the Pascal. We had taken this idea from the Pascal and introduced it into the Java. That is write once. Anybody know about this? What does this mean, write once and run anywhere? And why is this not possible with the C++ code? It is not possible with the C++ code. Anyone has any idea about it? Let's understand this very important point here. Yes, Zahid. क्या बोल रहे थे आप?
So portability.
No. It's not about portability. It's about different. It's a totally about the architecture, how we run it. It's about the JVM.
वही बोल रहा हूँ मैं. वही क्या?
V here means virtual, Java virtual machine. This is the first thing, whatever Java you read, this is the first thing we have to learn, Java virtual machine, that we have write once, run anywhere. What does that mean? Let's understand, because we have got some 8 minutes. In this 8 minutes, we understand without wasting time. And this is, if you understand this, that means we have learned something. Okay, everybody with me? What happens in the C and C++ kind of languages is, I will show it, make a new slide here. what happens with the C++ kind of languages is, what is this going on here? 1 second, please. I don't know, so I'll leave it. We have a C and C++, we have a compiler. We have a compiler, and you put a C or C++ code here on this side, and compiler is always linked with the assembler. You remember that. Compiling and assembling, it is a one piece, it's a two-step job actually, not a one step. And when the compiler comes in, you know जो आपके C और C++ में compiler थे, आपको compile करते हैं, वो असल में बाद में assemble भी होते हैं. You know, you create a, for example, .c or .cpp code, whatever you create, you give it to the compiler. .creates .obj object file or .o, we know that. Okay. Then using the assembler and linker, it creates .exe. And this exe runs on the system, but it's a tight process. It is like that. I'll give a little example first to make you understand it. Okay. So what I'm saying is listen carefully what I'm saying. You have a kitchen. I'm giving you a recipe. I'm giving you a recipe how to make a biryani, for example. Let's have a biryani party. And I'm giving the recipe. And we went to the Uzair Qadir's house, and I just see what kind, because I went there, and because I have to make the recipe, I went into his kitchen and I see इसको stove यहाँ पे है, यहाँ pressure है, यहाँ पे oven है, यहाँ पे ये चीजें हैं, और मैंने रेसिपी लिखी हार्डवेयर के हिसाब से, जो मुझे हार्डवेयर दिख रहा है. ठीक है. अब इस हार्डवेयर के मुआफिक मैंने इस रेसिपी को कन्वर्ट किया और बोला उज़ैर कदरी को बिरयानी बनाओ, उसने बनाई. ना अगर हम यही जो मैंने जिस हिसाब से मैंने ये रेसिपी बनाई, ना वी गो टू द से दानिश फयाज़'s हाउस. आई एम मूविंग टू द दानिश फयाज़'s हाउस, एंड वहां इफरा फारूक फिर से आ गई कुछ एडमिट. वहां क्या मसला है कि जो मैं बोल रहा हूं कि जनाब आप ओवन में डालो, वहां पे ओवन इधर नहीं, वहां इधर है, या मे भी ओवन ही नहीं है. मैं बोल रहा हूं कि इस शेल्फ में ये वाला पतीला है, उसमें डालो, वहां तो वो पतीला ही नहीं है, वहां तो कुछ और ही है. ठीक है. इज इट पॉसिबल कि जो कि उज़ैर कदीर का किचन के में हार्डवेयर होगा वो वही हार्डवेयर दानिश के होगा? सो इज इट पॉसिबल दैट AMD का जो मेरा हार्डवेयर है वो इंटेल का भी सेम है? वो तो टोटल डिफरेंट है. ठीक है. लेकिन यहां पर जब हम कोड को कन्वर्ट करते हैं, C++ में जब हम कोड को कन्वर्ट करते हैं इनटू द exe, असेंबलर ने देखा होता है हार्डवेयर, कंपाइलर असेंबलर एक ही साथ होता है ना, एक ही, असल में वो एक स्टेप, एक्चुअली टू स्टेप प्रोसेस है. असेंबलर इज वर्किंग ऑन द कंपाइलर, सॉरी हार्डवेयर. It is converting your code as per the hardware of a machine. So this is a machine, it is creating a exe, which is a machine code, and this machine code can run only on this system or the system like these. For example, मेरा यहाँ पे इंटेल का ये प्रोसेसर है, वैसा अगर आपको भी यही बिल्कुल यही आर्किटेक्चर है तो ये exe आप पे भी चलेगी. लेकिन अगर आपको इंटेल के बदले आपको मैकबुक है, ठीक है, उसमें तो चलेगी नहीं, क्योंकि ये जो exe बना है किस हिसाब से बना है? मेरे हार्डवेयर के हिसाब से. समझ में आ रही है? ये बड़ी बॉटलनेक है. ठीक है. तो इस चीज को जो इंपॉर्टेंट जो सबसे चीज है वो जावा ने इस्तेमाल किया. जावा ने कहा यार तू exe मत बना, तू एक इन बिटवीन कोड बना कॉल्ड बाइट कोड. ओके. फिर जैसी तेरी मशीन है, जैसे किसी को इंटेल की मशीन है, किसी को AMD की मशीन है, किसी को कुछ और है, मैकबुक है वगैरह वगैरह. ठीक है. उनका टोटल डिफरेंट आर्किटेक्चर है. तो आप एक काम करो सर, आप उसमें अपना JVM वर्चुअल मशीन डालो, और जो आप यहां से एज ए प्रोग्रामर कोड को कंपाइलर कन्वर्ट करता है, कंपाइलर जो आप जावा कंपाइलर लगाते हो, वो इसको exe नहीं बना रहा है, वो इसको बाइट कोड बना रहा है. डॉट क्लास फाइल बनती है, डॉट क्लास फाइल बनेगी आपको. ठीक है. कम ऑन. ओके. अबे लिख क्यों नहीं रहा यार? ओके. समथिंग इज हैपेंड. ड्रॉ पे क्लिक करना था. सो डॉट क्लास फाइल बन रही है, विच इज a general purpose file. It is not about the typical hardware what I have, and it is given to the JVM, and JVM will be platform dependent. JVM will be as per the platform. Intel का है, AMD का है, उसका अपना JVM होगा. जैसे आपकी मशीन होगी वैसा आपका JVM होगा. ठीक है. तो लेकिन जो आप कोड एज ए प्रोग्रामर बना रहे हो, वो आप एक इंटरमीडिएट कोड बना रहे हो, आप नहीं उसको कन्वर्ट कर रहे हो इनटू द मशीन। सो अगर ऐसा होगा फिर वो दूसरी मशीन में चलेगी नहीं। अब जो मैंने एज ए प्रोग्रामर कोड बनाया, मैंने क्या बनाया, बाइट कोड। क्या बनाया, बाइट कोड बनाया, एक सी बनाया, बाइट कोड बनाया ना। अब ये बाइट कोड मैं जेवीएम को दूंगा, जेवीएम का काम है वो आगे करे उसको कन्वर्ट। तो दैट मीन्स कि आई राइट वंस, सी I write here once this code, I write once and it can run anywhere, can run on AMD, it can run on other machine, it can run on other processor, it can run on other processor, any kind of processor it can run. So this is called as write once and run anywhere, which was not possible in case of C and C++, because when you compile it as per the system, as per that system. So it is going to run only on that system or the system like that, not in the other hardware. It's not going to work because it will hand up, because it's not made. जैसे मैंने किचन की एग्जांपल दी, जो अगर इसके इस प्रोसेस की, इसकी रजिस्टर्स की कैशे इसके किस हिसाब से इसने बनाया, it will not work in the common sense. ये कहाँ चलेगा दूसरे जिसका आर्किटेक्चर ही डिफरेंट है, उसकी कैश मेमोरी अलग है, उसके रजिस्टर्स दूसरे किस्म के, उसका वर्ड साइज दूसरा, तो वहां पे कैसे चलने वाला है। इवन 32 बिट ऑपरेटिंग 32 बिट पे आपने बनाया जिसके वर्ड साइज 32 है, उसी आर्किटेक्चर इंटेल का ही 64 लेकिन तो उसमें उसको प्रॉब्लम हो जाएगी। तो बात ही नहीं है कि अगर आर्किटेक्चर डिफरेंट होगा। डज इट मेक सेंस? ये समझ में आ रही है? इसीलिए इसको यहाँ पे एक पॉइंट ऐड करना है, जावा इज आर्किटेक्चरली न्यूट्रल, जावा इज आर्किटेक्चरली इंडिपेंडेंट और न्यूट्रल मींस इसमें आर्किटेक्चर का कोई दखल नहीं है। लेकिन सी एंड सी प्लस दे आर डिपेंडेंट ऑन आर्किटेक्चर, जैसा आर्किटेक्चर वैसा ही है। वी हैव अबव 1 मिनट ओनली, ओके, क्योंकि भाग जाएगा ना बीच में ही। तो ये इस बात समझ आ गई सबको? दिस इज वेरी इंपॉर्टेंट पॉइंट। हाँ जी।
Yes.
अब ये वेब पे चलता है, इंटरनेट पे चलेगा, क्योंकि आपके पास एप्लेट्स हैं, आपका वाइड स्प्रेड एक्सेप्टेंस है, क्योंकि कोई प्लेटफॉर्म ही नहीं है जहां पे जावा नहीं चलता। ऑल द प्लेटफॉर्म्स यू सी जावा इज देयर। हाँ जी, ठीक है। So what is this dialogue? We will like to, because this is end, because it's only just 1 minute left. I would like to say, why is Java called as write once and run anywhere? And Shahid Hamid Saab will tell us this thing. Shahid sir. रोशनी दी बात मत लिख रहे।
Yes, sir.
I'm saying, why is we say Java is write once and run anywhere?
Sir, platform independent.
How it becomes platform independent?
Sir,
आप ठीक बोल रहे हो।
सर जी, अगर हम किसी सिस्टम में यूज करेंगे जावा,
हाँ,
तो सर जी हम किसी और भी सिस्टम में यूज कर सकते हैं थ्रू जेवीएम।
हाँ ठीक है, लेकिन अच्छे से नहीं बताया आपने, लेकिन आपने बताया ठीक। Any other guy who can add up this thing in a right, tell us in proper way?